What year was I looking at earlier? 2012, wasn't it? Past papers, IFY, maths 2012, business, version 2. Let's go back to version 1 and see if there was a binomial in that marking scheme. Okay, let's have a look. No. Oh, there's something we haven't done. Well, I mean that we haven't revised yet. I tell you the random variable. Well, they tell you the random variable has a mean 12 and variance 18. What is the mean and variance of 4y plus 6? Interesting and kind of familiar? No? Well, try that, see how you get on. Malik, you'll get the door. Thank you. Who have we got? You're here for extra maths?
Yes.
Interesting. Interesting. No, I can't with the, because then it'll go blurry. Oh, you just want me to zoom in, is it?
Yeah.
A bit more, huh? There you go. We're doing number 3 here. You finished, Nina? Okay. Not happening? I'll have a marking scheme open too. If you know how to do it, it will take you 1 minute. If you don't know how to do it, it will take you forever. It's actually very good for 4 marks. Is it 4 marks?
Yeah.
It's really good for 4 marks. If you know how to do it. Which nobody does. Nobody does. Okay. So, what is it? 2y, or what was the 4y plus 6. And you're told the mean is 12 and the variance is 18. That's what you're told. Okay, so first let's calculate the expected value of 4y plus 6. That's equal to 4 times the expected value of y plus 6. That's a 4, by the way. Which equals 4 times 12 plus 6, which is 48, plus 6, which is 54. And then we want the variance of 4y plus 6. I don't know if anyone remembers this one.
E squared.
It's 4 squared variance of y, and we don't care about the 6. So the answer is 16 times 18. 288. Let's just check the answer there. Yeah. These are all good questions. So I take it you've forgotten this lesson. The lesson was called, funny enough, expectation and variance. Yeah. It's like it seems familiar, like we've done it sometime in the past. And this is the reason why it's important to revise.
You have done this.
Oh, I know we've done this. I definitely know, because I remember making and teaching the worksheet.
No, a couple of these as well.
I'm sure I did more than one, yes. Okay. We continue then?
Yeah.
is the only revision that's happening in class. This worries me. Maybe you should do some revision at home by yourself.
Yeah, we do actually.
Do we?
Yeah.
Do we?
I have all the revision samples here.
Except this.
No, I have all fine.
Maybe you need to do revision of the revision. Yeah. All right. We'll continue then. Let's see. Blah. Okay. You're probably very comfortable calculating correlation since you've just done your assignment a few days ago. Notice though in the exam they kindly give you, this is Sn, but n and t are like x and y, okay? So this is Sx, Sy, what's this one? Sxx, Syy and Sxy. So as long as you know the formula, you can get the answer. So there's nothing special here. It is, but in a weird way. You're better off remembering the way I gave it to you.
To find the A and B value.
You just did an assignment on this.
I know, but I'm saying they don't give you the formula in
No, they do, but it's weird, and it's not like the way I gave it to you.
It's quite different, I think.
It is quite different, yes. So my formula is more straightforward. Just put in the numbers and you have the answer. Yeah. Anyways,
Xy over X, Sy.
yeah. What the heck does that mean? Yeah, it's different to what I do. I want to do binomial. Let's see if I find a binomial. That's what we did something like this. No binomial in that one. Let's go, and I don't remember seeing anything in version 3 or 2, so we'll just jump to 3. Maybe there was no binomial that year. Happened. I'll jump back up to 2013. Oops. Alright, let's see this. No. Lame. No.
What was that question about economics?
Lame. No binomials in the year 2012. We'll have to go to 2013. Bad year for binomials. Right, let's zoom out a bit. I don't know. We'll find out in 2 weeks. I don't know because I didn't teach September business. I'll have to ask the other teacher. No. Here we go. There we go. Give that a try. 10 people are selected at random. What is the probability that fewer than 3 of them were born on a Friday? I'll zoom in for you.
Does the 3 include this or?
Now that I'll let you decide.
2, 1 and 2.
I'll let you decide. Victor, do you have you have a formula book there?
Yeah.
Can I just check something there? I want to see if one of the values are in it for P. Close. Finished? Oh. Oh dear. Might be time to panic, so. If you remember at the start of the year, I said I would tell you when is the time to panic. I think we're getting to that moment. Okay, can we do it now? Yep. So there's two ways to do it. The first way, well, first we have to write down the information. So, how many people do we have? We have 10. And how many successes do we want? 2 or less. So we're looking at 0, 1, or 2. And what's the probability of a success? A success being born on Friday? 1/7. So the probability of it being less than or equal to 2 will be the probability of getting a 0, a 1, or a 2, which would be NC0, 1/7 power 0, 6/7 power 7, plus, why did I write n? It's 10. 10C1, 1/7, 1, 6/7, 6, plus 10C2, 1/7, 2.
It's 9, not 6.
What is wrong? Thank you. What's wrong with me? And here is 8.
The first one as well.
10. I'll write that in again. 10.
And 9, 8.
10, 9, 8, yeah.
5.8.
Oh no, has to be less than 1. For sure, the probability. However, you can get the answer by looking up the table book with P equal to 0.15. It's the closest I can get. And X equal to 2. So what answer does that give you, Victor?
0.8202.
0.
8202.
Sorry, 82 then. You sure? Seems awfully big. Are you looking at the table right?
Yeah, 0.82.
Okay, 0.82 then. How does that compare with the exact answer?
0.8385.
So it's off by 0.01 then. Okay. So if you do it this way, you get 0.8.
8385.
So 8385. So that'd be a 9 then, if the three significant figures. It's a little different. It's a little different. Yeah. What's wrong?
How do we know if we should include the 3 or not?
Where, here? Oh.
Just you would agree.
Oh, okay. I don't know. It feels like I shouldn't include it. It's a grammar thing or something, I guess. Read it out exactly. Well, let's see here. It says fewer than 3. So it's like under 3. How could we say it if we wanted to include the 3? Yeah, okay, yeah, good, true. But using the number 3. 3 or less is how we say it in English usually. Or if they wanted to include the 3, they would say 3 or less, or 3 or fewer. But this one here, I don't think I should include the 3. Yeah. You don't look sure, Nina. It's okay? You sure? Yeah. I don't think we should use the table book here because it's not quite the same. And I think maybe that's why they picked 1/7 because it's not in the table book. It's nearly in the table book, but it's not.
14/8.
14/8, yeah. Okay. Let's see. So here's your chance to prove yourself. Try number 5 now. How many marks? 4. Okay. Finished? Leon? Finished? Yeah. Okay, will we do this one now? Yeah. So, what was the first equation they gave me? Expected value of 3x plus 10 equals
45 times
equals what?
45 times
Okay, and then variance,
3x plus 10.
oh, the same thing, of course, yeah, equals 3.2. Right, so I think this one looks nice to look at first because you can change that into 3 squared variance of x equals 3.2. So variance of x equals 3.2 divided by 9, which is?
0.356.
And then here we can have 3 times expected value of x plus 10 equals 45.6. So expected value of x equals 35.6 over 3, which would be 1, 1, yeah?
87.
So 9 then. It's not bad for 4 marks. Again. What's the
Why
problem?
do you have to square for the second one?
That was the rule.
No, this one.
And it's not in this one.
No.
Check your notes. Because we talked about this in class, so just check your notes then for this. The rules for these. Yeah. I don't think these rules are in the formula book with expectation and variance.
No.
So you're going to have to review your notes, okay? Right, do you have this, Marcelo? Dude, get off the phone. Who are you talking to him then? You adding entries to Urban Dictionary.
We're not doing anything.
I'm relaxing. Watch me relax. Okay, we continue. Right. That partial fraction's okay. That actually we did that one, didn't we? Yeah. So did we? Let's see if there's another binomial here. Scatter plot.
This one.
This is expectation and variance as well. So we might do that. We did the tree already. This is the trend lines. That's the core cumulative frequency. I don't think we did functions and mappings, did we? That's not. No, you were complaining about the
Yeah.
engineers had that, yes. So I think we'll finish this exam by just having a look at the expectation and variance here. Oh yeah, we'll see if you remember how to do these. So this is a probability table, and from the table you want to calculate the probability x is 3, greater than 3, the expected value of x, and that one's interesting, probability x is 3 given that x is greater than 2. So do you remember we did these tables with like the horse racing and things like that? So in the last one it's like x is greater than 2. Oh, that's stupid, no. I'll let you figure it out yourself. Don't forget it, I'm not talking right now, figure it out yourself. It's actually easier than I thought. Well, okay, maybe it's not as easy as I thought.
What?
In the last one, hang on. Here it says x is greater than 2. So it's like this one fell out of the race and it's just these ones left. Anyway, now let's try and figure it out. It's a bit like the horse racing example we did in class. Yeah, that's the verb, very good. Well, that's one way to do it, yeah. Did you remember renormalize, or you saw it in your revision recently? No. Okay. That first one has to be only 1 mark, right? Yeah. Although the second one's also 1 mark. Doesn't seem fair. Finished? No. Leon, you know what to do? Malik? Oh.
That's the first two.
Thank goodness for revision. I don't see how that will help you. Don't you have notes you can be checking? Okay. Let's do this one, I think. First one, we can see the answer already. What is it? 0.4 is the probability of getting a 3. What about greater than 3? Well, greater than 3 means getting a 4 or a 5, which is also 0.3. So that's easy. Now, how to get the expected value? Does anyone remember that?
Sum of
That's it. The expected value of x is the sum of the x's multiplied by their probability added up. So what's the first value of x? Is it 1? Starts at 1? No, starts at 2. And the probability of a 2? 0.4. And the next one's a tray with 0.3, isn't it? And the next one's a 4 with 0.2. No, it's not that, sorry. The next one is a tray of 0.4, and the next one's a 4 of point. Oh my goodness! Right, let's start again. 0.3 plus tray 0.4 plus 4.2 plus 5.1. So that would be 0.6 plus 1.2 plus 0.8. That's 2.05? Is it 2.05? 2.65?
0.5.
Huh? 0.5. Oh, thank you, sorry. 0.5, so that's 3.1.
Yeah.
Okay.
You're the next.
Yes, that's the funny thing with maths. Right, then the last one is the probability that x equals 3 given that x is more than 2. So if we look at our table,
Use the formula.
yeah, you can use the formula. We'll do it both ways. 2, 3, 4, and 5. So this is 0.3, 0.4, 0.2, and 0.1. So you want the probability that x is 3. But you know it's more than 2, which means this one is gone. So like Victor was saying earlier, you have to re-normalize, which means you have to make the total 1 again. What's the total at the moment? 0.7, yeah. So this one, you have to divide each of these by 0.7 to re-normalize it. So the answer will be whatever 4 over 7 is. 0.57. And as Malik was saying, you can use the formula. So what would be the formula here, Malik? Impress me. Ah, you just had the idea, huh? Right, so on the top is probability that x is greater than 3 and x is bigger than 2, divided by the probability that x is bigger than 2. What is the probability that x is equal to 3 and it's bigger than 2?
It's the probability of
It's the same as the probability that x is equal to 3. Why? It's already bigger than 2. You get the bigger for 2 for free. So, what is the probability that x is 3? 0.4. And that x is bigger than 2? Wait, that looks familiar. We get the same answer. Amazing. So both ways work. Yeah. Continue. I said there was nothing else interesting here, wasn't that right? 4 in. Okay, let's have a look. What year was that? 20 something. Let's have a look at. Was that 2013? Probably was. Let's have a look at 2014. Business version 1. Okay. No, thank you. lame, so. We did the binomial on this one, didn't we?
I did that.
Yeah. But did we have a look at do I have 20? 15? No, always empty. Let me see if I got it somewhere else.
Why don't you just send these exams by email to us? Like
On Moodle, isn't it?
Mm.
Like Donna.
It's on Moodle. I'm not Donald. I'm Stephen. And I put it on Moodle. Can you see 2014 to 2015? I can't.
No. Mm.
This is the one we were looking at, wasn't it? Alright, we'll just have to go further back in time. So we go back to 2011. This kind of looks familiar. Were we just looking at this one?
Yeah.
Right, back one step more, 2010
Okay.
to 2011, then let's have a look at what we got here. Version 1. Right. Differentiation. Right, that's science maths, not business maths. I knew something wasn't right. But they don't do that. Oh, I only have one business one here.
Yeah.
Alright, what I'll have to do. Okay, let's see. This is averages, product rule, expectation and variance. You don't do that, you don't do that. That one is okay. That is correlation, substitution, median, frequency table. I think we'll do that one. Maybe that one. Let's have a look at that one with sets in it. Now, is the B... Yeah, it's different. Okay. Alright, so we'll just have a look at this one here, and then we'll finish with that for today. So this is a probability one of A, B, and C. So do you remember these are the ones with the Venn diagrams?
The most difficult thing is that
What?
in diagram.
What's most difficult? This one? You say that about everything.
No, this one. The most.
Okay, see how you do then. I think we did this in semester 1.
Yes.
Yes. Marcelo, come on. So the first thing you need to draw is the Venn diagram. The 3 circles. Seeing lots of thinking, not much writing.
What doesn't depend on me?
Ask Malik from semester 1 if he remembers. Malik in semester 1 knew what it meant. Yeah. Malik in semester 2 does not. Independent, you remember? Do you have your notebook?
No, I don't have my notebook.
Think back.
Go for it.
The first part, did it say A and B dash or?
That's a dash. In this one here,
Yeah.
that's a dash, yeah.
Probability of A implied by probability B
Is what?
minus
Is what? Is what? What? Oh dear. Oh dear. Alec.
Google.
Google what?
Then
Let's do it. Right. So you have three events, A, B, and C. So the Venn diagram looks like this. There's A, B, and C. Okay. Now the first thing is probability of A is 0.4, B is 0.6, A and B are independent. Find probability of A and B. So actually in the first question, it has nothing to do with C. So if you want to go back to your Venn diagram, you can draw the C in later. We'll just do the two to begin with. A and B. Okay, so what are we told? A is 0.4, B is 0.6. A and B are independent. So where do we put 0.4? Where's 0.4?
the left side.
See, all of this is 0.4, and all of this is 0.6. So we call this X.
0.4 minus X.
Yes, this is 0.4 minus X, 0.6. Oh wait, what was it? 0.6 minus X. But we're also told that A and B are independent. So if A and B are independent, that means probability of A and B equals, yes?
A minus.
Minus?
Multiply.
Multiply? That's it. So we get here that X equals 0.4 minus X times 0.6 minus X. So X equals, what's that, 0.24 minus 0.6 minus X? Yeah? Minus 0.6X minus 0.4X plus X squared. X squared minus 2X plus 0.24 equals 0. Is it not minus, this one is minus 0.6x and this is minus 0.4x, so total minus 1x. Let's solve this. I get two answers, but I only use the answer that's between 0 and 1. So the answer for this quadratic is x equals 0.128. So now when I draw the Venn diagrams again, that's A, that's B, that's 0.128. 0.272 and 0.6 minus 0.128, 0.472. Yeah? Sigh! I don't know why my brain did that, to change the 1 into a 2. Right, let's resolve that quadratic. Ah, beautiful answers now. Oh, interesting. We have two answers. Now, someone's going to have to tell me which one to pick. 0.6 or 0.4.
0.6.
Why? Yeah, if you go back to the question, this must be positive and this must be positive, which means x has to be smaller than 0.4. Well, I suppose it could be equal to 0.4 as well. It just needs to be bigger than or equal to. It couldn't be 0.6, because what would happen if x was 0.6 here? It'd be minus, so that would be quite bad. So that's interesting. If this is 0.4, then here is,
0.
and here is
1.2.
2, and outside 0.4.
0.4, yeah.
Yes.
Now it's easy. You know when you're like revising the old towards your mind,
Revision?
you find something there.
There is something there. But I wonder if, I feel like something feels, my spider senses are telling me something's wrong here. No, that's okay.
I think it's supposed to be minus 2x. You bring the x over. Yeah, but
I was right the first time.
how do you feel amazing?
Who told me it was supposed to be 1?
I asked you, I was like...
What's that word? Fleek? Now I know what it means. It means troll. Just trolled your maths teacher.
Problem.
All right. Let's do it again. Right, so what's in the middle? We had it a moment ago. 0.128, and here? 272, and here? 472. Okay, and then have we calculated the outside? I got 0.128. Okay, what did the question ask me for, though? It wanted A and B. Well, there you go, there's A and B. And what else do we want? A and not B. So what would be A and not B? That's it, that's one there. Okay? Yep. Right, next part. Now we add in the C. So the C is 0.5, and A and C are mutually exclusive. B and C is 0.35. Okay, so I'll just draw this again, but what does that mean? A and C are mutually exclusive. Anybody? Person who is laughing clearly knows what it is. What's it mean? Oh, come on, not even a guess? Using your English powers? Thanks. Anything else? A and C are mutually exclusive means they cannot happen together. Their probability is 0. Okay? So A and C are impossible to get together. So that means this and this is 0. Can't have them. We're also told that B and C is 0.35. So B and C is 0.35. But we still know that this is 0.128, and the total here still needs to be 0.272. what does the total here need to be? 472 for here, or the whole circle is 0.6, isn't that what we said? So we can still work out that 0.6 minus 0.128 minus 0.35, so this is 0.122. And we're also told that C must be 0.5. So how can I get this here, or what must this be? 0.5 minus that, which is 0.15. And then lastly, I need the number outside. 1 minus 0.15 minus 0.35 minus 0.122 minus 0.128 minus 0.272. What? Negative. Unless it's not the same A, B, and C as the last part. Should be the same. Like 272, 128. C is 0.5. I didn't see any mistake. Maybe the mistake's with their numbers. Let's check. You also added up and got a number more than 1 on the inside. Quite bad. What number is that now? B2. This is right. This is right.
Wrong in the beginning.
The A and the E is wrong.
Your math guy will try.
0.24, what did I get?
How did we do the first one? Go back and check it.
What's the last one? That's it.
They just multiply the 2 there.
I know, but I should have got the same answer.
No, it's different. Go back.
Yes.
No, it's not. 0.4, they multiply.
No, I know what they did. I understand what they did. My point is, I should have gotten the same answer. Unless I miscalculated. Let's type it in my calculator again.
Either they're 0.4 minus 6 minus 6 minus 6.
It's not minus X and not minus 2X.
Yeah, we fixed it. We made it minus 2x.
No, but it's not
No.
minus X.
Well, what is it then?
The form in the answering sheet. they
No,
just-
forget about the answer sheet. I want to know what's wrong here.
You get 0.4 minus x, you multiply it.
No, I'm not.
Is that wrong or wrong?
I want to know what's wrong here.
In the quadratic, it's not X. Not X in the quadratic.
What is it then?
Instead of 2X minus 2X.
No, it is minus 2x. Huh? I get two answers here for x, and the second answer is 0.128. But at the marking scheme, I should have gotten 0.24. So there's some number mistake here. X is the middle, and we're told that A is 0.4. Yeah, so that's 0.4 minus X. We're told B is 0.6, so that's 0.6 minus X. Ah, I found my mistake. I'll give you a minute to try and find it too. I'll just sit back and wait.
0.4 minus X.
No?
You just multiply 0.4 by...
You're not thinking, you're talking. Look, think, and then tell me. You'll know it when you see it. I'm sure that's an internet meme, isn't it? You'll know it when you see it. What is it? No, you're doing that thing where you're talking until you guess the right answer. You'll know it when you see it. No,
Is it really obvious?
the moment I tell you, you're like, oh.
0.2x.
Yes. Thank you.
What?
The mistake was here.
So just,
I put in this,
multiply.
but that's not the probability of A. What's the probability of A?
It's 4.
Include it.
0.44.
Ah, dude. Right
I was
there.
trying to study that.
I know. I needed you to think of the sentence. Right, so this should have just been 0.6 multiply 0.4. Yeah, me too. How about we do this again next time?
Yes.
Yeah. I'll leave it up here if you want to take a picture on your phone, and you can do it at home. What worries me is it took so long to see that. See, we should have looked at the marks as well. It was only supposed to be 2 marks. Alright, we'll do this again next time. Have you got a class now?
Yeah.
What class? What room?
The